Here's an example where a beaker has been left out in the open, uncovered, and an original volume has now decreased a bit with time. I'll just depict it here with a little illustration so that literally everyone gets the picture. So we're starting with 275 milliliters, and the concentration is 0.105 molar NaCl. So that means that there is 0.105 moles of sodium chloride per liter of solution. And what happens to this, because the lid is left off, the level, we'll just mark it as going down, and the level goes down to 237 milliliters. Now you know that if you leave a solution out and the solvent, some of the solvent evaporates, we'll say that it gets more concentrated, right? So the question here is, what is the concentration? So we write concentration sometimes like this, square brackets. So that square bracket means, with the question mark, what is the concentration of NaCl in this final solution, let's say. So we expect that the number should be greater than this because it still has the same number of moles of salt, but it's in a smaller volume of solution. Some of the water has evaporated, and so that number then should be larger. So we can do a quick M1V1 equals M2V2, but I hate those little tricks, and let's just make sure that it makes sense. You can use that for sure, but you have to make sure that you also understand it at this level, at the following level. So concentration, as we say, is actually equal to, in this case, it should be the number of moles of sodium chloride per liter of solution. Okay, so let's fill that in. Okay, let's put it down here so I have some more room. And what's my number of moles? How do I figure that out? Well, I have 237 milliliters left, and I had 275 to begin with. So would you say that the number of moles of salt, because salt didn't evaporate, so the number of moles of salt that I have here still has to be the same in this case, because the only thing that left was the water. So the number of moles of salt at the end is actually equal to the same as it was in the beginning. It's the volume that's changed. And so to figure that out, I've got 0.275 liters of solution. And I know that in that solution, I had in 1 liter, I had 0.105 moles of sodium chloride. So these units will cancel and I'll be left with moles. So that's how many moles of sodium chloride were in here. But now I still have the same number of moles, but it's in a smaller volume. So my bottom unit I want in terms of liters of solution. I don't have a liter, I have 237 mils. So there's my final volume, 0.237 liters of solution. And see, that unit will cancel with this, so I'm left with moles of sodium chloride over liters of solution, and those are units of concentration. And on the calculator I get an answer of 0.1218, and it should be 3 sig figs, so I'll change that to, or round it to 0.122, capital M for moles per liter or molar sodium chloride aqueous, and that is my new solution concentration. And I predicted that the concentration would increase, and it has. So it started off as 0.105, and we lost some volume. Some of the solvent water evaporated, so it got more concentrated, and indeed it went up to 0.122 molar. So you try this one on your own using molarity 1 V1 equals molarity 2 V2, and you would be solving for the new concentration. So M2 is equal to M1 V1 over V2. So let's just look quickly. The new concentration would be equal to the old concentration times the original volume divided by the new. And isn't that essentially what we did? There's M1, 0.105 molar, times V1, 0.275 liter, divided by V2, 0.237 liter, and there you have it. Alright, so it doesn't matter which way you do it. Even if you do it this way, you would have to put in all your values with their units. So both would be fine, but there you go.